In this video, I'm going to show you how to solve a projectile motion problem, and this one is inspired by a scene from The Bourne Identity, in which Matt Damon sprints down a hallway, jumps out a window, and crashes through the window of an adjoining building. If you're into action movies, you can probably think of your own example of a similar scene, but if you want to see this scene for yourself, just Google Bourne Identity window jump and you'll find it. So the question we're going to answer is, what initial velocity is required to complete this jump? And we're going to make an assumption that the initial velocity is completely horizontal. Now, before I go on, I should say that even after you watch this movie and understand how to calculate the minimum velocity, you should not try this jump. Remember, Jason Bourne is a highly trained government operative, and even he used a stunt double for this scene. So please be safe. I don't know the exact distance between buildings or the vertical drop for this jump, so I'm just going to make some estimates based on how things look in the movie. Let's say that the horizontal distance between the buildings is about 4 meters and the vertical drop from one window to the next is 2 meters. Believe it or not, that's all the information that's required to determine the horizontal velocity. For projectile motion problems, it's always helpful to remember that the motion may be distilled into two motions: the motion that's happening in the horizontal direction and the motion that's happening in the vertical direction. I like to set up two columns, X and Y, to keep the information organized. For projectile motion without air resistance, the accelerations are always known. The horizontal acceleration is 0 because the velocity is not changing in the horizontal direction. And in the vertical direction, the object is subject to gravity, so the acceleration is negative 9.8 meters per second squared. Now, by calling the acceleration in the y direction negative, I've made a decision that in this world, down is negative and up is positive. And it's important to remain consistent with those decisions throughout calculations. The horizontal velocity is not changing, so v0x is equal to vfx is equal to v0. Meanwhile, for a projectile launched horizontally, the initial velocity in the y direction is 0, and I don't know what the final vertical velocity is in the final vertical velocity is. I don't know how much time this jump takes either, but I do know that the time is the same in both columns because it takes the same amount of time for the horizontal motion to occur as it takes for the vertical motion to occur. Finally, as I said earlier, I'm going to say that the horizontal distance between the buildings is 4 meters, while the vertical distance is negative 2 meters. And once again, I declared down to be negative, and since the jumper drops by 2 meters, I have a minus sign before the 2. Okay, once the lists are filled out as much as possible, it's time to use the constant acceleration equations to start working toward a solution. By the way, if you want to fix up the original constant acceleration equations for the horizontal direction and really emphasize that these deal with things on the x list, you can do this. And likewise, for the vertical direction, you can write the equations this way. Anyway, for this problem, the goal is to find v0, but there isn't enough information in the x column to go directly to the answer. You can play around with the equations and convince yourself that you really need t in order to find v0. Luckily, we can go to the vertical column to find t. Here, you can see that there are 3 bits of information filled out, so it should be possible to find an equation that contains these 3 quantities as well as time. The first equation does the job, and after making substitutions, we find the time is 0.639 seconds. Add those to the columns, and now we're in a position to solve for the horizontal velocity. I'll change my constant acceleration equations to emphasize the x direction. And now notice that we have these 3 quantities complete in the x column. And you can look again at the constant acceleration equations to determine which one will be the best. Once again, it's the first equation. Notice that because the acceleration is 0, the final term 1/2 axt squared goes away. And so I can make substitutions and find that the initial velocity is 6.3 meters per second. So whenever you finish a problem like this, you should take a minute to think about whether or not the result is reasonable. So if you figure that each stride is about a meter, Jason would need to take about 6 strides in a second to achieve this speed. You can look back at that video clip and see if that seems about right. Of course, I've made some estimates and one big assumption that the initial velocity is horizontal, so don't get too crazy timing strides or anything, but just check to see that the answer seems to be in about the right ballpark. To end, I'll point out that in fact the initial velocity of Jason Bourne is likely not perfectly horizontal. I imagine he jumped up a little bit as he left that first building, which means that part of his velocity was vertical, and that makes things a little bit more complicated. If you'd like to see an example of a projectile motion problem where the initial velocity is not totally horizontal, you can check out the next video.